Welcome to my channel. In this series, we will solve thermodynamic problems. Today's problem is a monoatomic ideal gas of 2 mole is taken through a cyclic process starting from A as shown in figure. This is the given figure. The volume ratios are Vv by Va equals to 2 and Vd by Va equals to 4. If the temperature Ta at A is 27 degrees centigrade and the gas constant is R. Calculate A, the temperature of the gas at the point B, and heat absorbed or released by the gas in each process, the total work done by the gas during the complete cycle. This is the diagram. The gas is taken from A to B, B to C, C to D, and D to A. And this is Vt diagram. The y-axis is V and the x-axis is T. Here all these are marked. This is Ta, this is Tb, this point is Vv, this point is Vd. Here Vv by Va is 2 as per question and Vd by Va equal to 4. Number of mole is 2. For monoatomic gas we know Cv equals to 3 by 2 R and Cp equals to 5 by 2 R. Now we assumed here Va equals to V naught, say, so Vv equals to 2 Va, that is equals to V naught, and Vd equals to Vc. It is clear from this diagram, and which is basically here Vd by Va, Vd equals to Vc, that is 4 V naught, and Va is V naught, and Ta equals to 27 plus 273, which is approximately 300 Kelvin, roughly. Basically 2273.15, I discarded 0.15. First part, the temperature of the gas at the point B. Here V is proportional to T, keeping pressure constant, isobaric process. PV by Ta, PVA by Ta, that is equals to PVB by Tb. PP cancels out, Tb equals to Ta, Vb by Va. And if we put all these numerical values, this will be 600 Kelvin. Number B, heat absorbed or released by the gas in each process. Now A to B, pressure is constant, A to B. Here for your reference purpose, the diagram is copied, and a pressure is constant in this part. Here there must be some arrow like this. It is a cyclic process. Pressure constant, therefore heat absorbed, basically heat absorbed, that is N times Cp, specific heat at constant pressure multiplied by a change in temperature dt, Ncp Tb minus Ta, 2 into 5 by 2 R, 600 minus 300, that is 1500 R. Heat it is absorbed because it is plus. Our assumption is that plus means heat absorbed, minus means heat released. B to C, temperature constant as shown in the diagram is evident from the diagram. T is constant, so du is 0, that means there is no change in internal energy for an ideal gas. It is not true for real gas. So dq from the first law, dq equals to du plus dw, so dq equals to dw. That means heat absorbed, or basically heat absorbed in this case, that is equals to work done. And we know for isothermal process, it's an isothermal process because temperature is constant here, and nRT/Tb log Vc by Vv, Vc by Vv, and this is evident 4 V naught by 2 V naught, and if you calculate this, and this will be something like this. It is heat absorbed because it is a plus. In the CD part, isochoric process, because temperature changes, there is no change in volume, and QCD equals to NCV multiplied by TD minus TC, change in temperature, not CP, it is CV, it is isochoric. It's an isochoric process. Isochoric process. And if we put all this 3 by 2 r and this will be a negative sign minus 900 r, heat is released in this case. And the DA process, again isothermal compression, because volume is changing and it is decreased Vd to some Va. Here the value is basically Va, and in this diagram this is basically Va. And in this process T is constant, so there is no change in internal energy, and U is constant, so Q dA equals to W d to A nR Td log Va by Vd. I'm putting these values is 1/4, and due to 1 is log 1 is minus log 4 is minus, and this is something like this, heat released. And these are the all of the calculations for B, heat absorbed or released by the gas in each process. The rest part is the total work done by the gas during the complete cycle. Now, in a complete cycle, there is no change in internal energy because there is no change in temperature when it returns back to the point A at this point, as there is no change in temperature for ideal gas. Total work done by the gas, which is basically how much heat is absorbed, and if you sum this, you will get basically the work done. And if you sum this, this is the work done. Thank you for watching. Please like, share and subscribe. If you have any doubt or discussion, or you have any request for problems, you can write in the comment section. Thank you again.